Hydroelectricity, derived from hydroelectric power, is one of the oldest and most widely used renewable sources of energy in the world. From powering vast industrial complexes to bringing light into our homes, this ubiquitous source of power has facilitated significant advancements in society and transformed how we live and work. It all began in the late 19th century when water was first used to generate electricity. The first hydroelectric power station was developed in Craigside, Northumberland, England, by William Armstrong in 1870. The technology rapidly expanded, and by the 20th century, large-scale hydroelectric power stations were introduced, and some of the most monumental constructions at that time, like the Hoover Dam in the US, were built. Hydroelectric power operates based on a relatively simple principle, utilizing the potential energy stored in water. This energy is mainly derived from the water cycle, which is driven by the sun, thus making hydroelectric power a form of solar energy indirectly. In a typical hydroelectric plant, a high dam is built across a large river to create a reservoir. The potential energy of water stored in the reservoir is released to turn a turbine, which then drives a generator to produce electricity. The significance of hydroelectric power cannot be overstated. Hydroelectric power reduces reliance on fossil fuels, thereby contributing to energy security and reduction in greenhouse gas emissions. Unlike wind and solar power, hydroelectric power is not intermittent, providing stability and efficiency to the energy grid. Furthermore, the flexibility of hydroelectric power plants allows them to be used as a means of storing electricity in times of surplus, which can be released when demand is high. While hydroelectric power has many positive facets, its drawbacks need acknowledging as well. High upfront costs are required to build dams, and their construction can take many years. Furthermore, hydroelectric projects often lead to large-scale displacement of local communities and changes in their livelihood. The vast reservoirs created by hydroelectric dams could inundate both human settlements and sensitive ecological areas, which leads to significant social and environmental impacts. One of the most monumental environmental impacts is the alteration of river systems, which could result in a loss of biodiversity. A hydroelectric dam changes a river's flow regime, modifies habitats, and might block migration paths for certain kinds of aquatic species. Additionally, large reservoirs could lead to an increased evaporation rate, reducing the amount of water available downstream, which might hinder agriculture and threaten water security. Besides environmental impacts, it is noteworthy that while hydropower is renewable, it's not completely green. The inundation of vegetated land by reservoirs leads to decay and decomposition, which releases a significant amount of greenhouse gases initially. However, the long-term operation of a hydroelectric power plant generally has lower greenhouse gas emissions compared to fossil fuel-based power plants. In conclusion, the vital role of hydroelectric power in our society is undeniable. It's a reliable source of electricity and an essential tool in our fight against climate change. However, its impacts on the environment and communities cannot be ignored. Moving forward, a balanced and integrated development approach must be adopted by considering not just economic factors, but also protecting the environment and upholding social justice. The continued use of hydroelectric power requires it to be part of a broader, diversified energy strategy, one that considers all aspects of sustainability.